and usually me and my partner, Addison Snell, do it together, and we ask the company reps 4 questions, and 2 of those are secret questions, and 2 of those questions they know ahead of time, and they have 90 seconds to answer those questions. We are not going to make things that hard here, because this is the first time what we're doing here. So here, we're actually going to, and the other difference also with ISC is that each vendor gets a unique question. So when I do it, we have 12 vendors, everyone gets 4 questions, so we have to come up with 48 unique questions. Here it's only 3 questions, everybody gets to see the questions, and in fact, the vendor reps already know the questions ahead of time. Of course, none of you know it. Now, the other thing that we do also is at ISC, we kind of ask the audience to rate the responses of the vendors, and whoever gets the highest point actually gets a little trophy at the end. Now, we are not quite set up for that, but Steve had a suggestion that we could do a applause meter or something like that, but we'll see how we're going to do it. But this is kind of a dry run this time. Maybe we'll figure this out for the next event. So the plan is I'm going to ask 3 questions, one at a time. The questions are going to be shown up here on the screen so that everyone can see that. And I would request that everyone pay a little bit attention, so it'll be nice to get your feedback at the end. And then every vendor rep will have 3 minutes, and we're going to run this really tightly, otherwise the fun of this whole thing goes away. So everybody will have only 3 minutes to answer that question, okay? And then we'll move on to the second question and the third question. Now, of course, to make things even harder, not only do I have 3 questions, each question is a 2-part question. So there's actually 6 questions. So in some sense, they have 90 seconds to answer each part of each of the questions. So we were supposed to have 5 vendors, but the huge argument that Deborah and I had over dinner last night, maybe Deborah decided not to show up, but I'm not exactly sure where Deborah is, because we were having arguments about self-driving cars and whether we should allow self-driving cars at all. Because she actually likes to do parallel parking, which many of us don't actually like to do. Anyway, so with that, I think we have 5 representatives here. We have John, who is from Altair? Okay, and your name is?
John Shelley.
Yeah, John Shelley, that's John Shelley. And then we have Mellanox, AV?
No, Kurt
Kirk Rago, okay, and then we have NVIDIA, Dale?
Southard.
Dale Southard, and Intel is not here. Spectralogic, or no, he's Rigetti. So Madhav, and then we have, and you are representative A-Star. Okay. So with that, I'm going to show the first question, and we'll go from this end to that end for question number 1. And so this is the first question, and you know, if you want to come up here, you can do that. We'll try to follow the clock over here. So how do you define a disruptive technology for HPC, and what exactly is your company doing in that field? So you can step up here, or it might be easier to just use the microphone, whatever you want.
Right, and this mic is live. This is one.
Your call.
Does that count against my time?
Yeah, it starts now. That's it.
Now, okay. Hi, Dale Southard from NVIDIA. So, as a quick introduction, my background years ago was as a computational chemist. Being at a company known for graphics and doing HPC and deep learning, I think it's been a while in the HPC industry since we've seen a really disruptive technology. Certainly we've seen things like, you know, the move from vector machines to clusters, the move to open source, multi-core accelerators, and each of those did displace the growth curve, meaning that we're, you know, ahead of where we would have been if we would have stayed on the vector path. But I think in a lot of cases, the disruption maybe was at the vendor side, in that there were some winners and there were some losers, and you bought things from a different company, or maybe a company with the same name that had different people in it or the same people at a different company. However it works, but HPC hasn't been known as a place where companies, flourish in the same form for 20 years. I think that's changing in that the real disruptive technology that's occurring, that's been mentioned a few times now, is the broader artificial intelligence field, and more specifically deep learning. And I say that not as deep learning for itself, meaning deep learning to build a speech-based interface or deep learning to look at big data, but I think you're going to start seeing deep learning as a component of existing apps, as part of your HPC toolbox, in the same way that GEM operations are part of your toolbox and FFTs are part of your toolbox. These things aren't going to solve every problem you have, but if you look at some of the emerging papers, like the ANI 1 paper, where they were using a deep neural net for density functional theory, and they're getting many orders of magnitude more efficiency than they get through traditional mod sim. So it doesn't necessarily replace the entire application. It just becomes something else in your mod sim toolbox that you can think of as a highly parameterized solver that really gives you a revolution in the kind of efficiency and kind of speed you get. And by that I mean, orders of magnitude, more than one order of magnitude. We've seen up to 100,000-fold improvement. As to what NVIDIA's doing, we're focusing on products that while they're great at deep learning, are also still good at traditional mod sim. An example would be the V100 processor that's going into the Coral systems and other systems. That is being purchased as a mod sim platform, but it's also giving them a peak of 120 teraflops per processor for AI type problems. That's a tremendous amount of capability that's there and can be mixed in live with the other traditional mod sim techniques on the science problems that they have.
Okay, so let's pass on to Madhav.
All right, thank you.
3 minutes.
Great. So my name is Madhav Tata, and I'm Chief Strategy Officer at Rigetti Computing. We are a quantum computing company, and we build general-purpose quantum computers. So why is quantum computing a disruptive technology? Well, the difference between classical, traditional computing and quantum computing is that every traditional computer, from supercomputers down to your iPhones, work the same way. They use bits that can exist in 0 or 1 states. A quantum computer's physical representation uses what's known as a quantum bit, which can exist in multiple states at the same time. So that's as much physics as I'm going to get into today. But the upshot of that capability is that quantum memory scales exponentially. So with every unit of memory that you add to a quantum computer, it doubles the capacity of the system. So if you added 10 quantum bits to a system, you would get approximately a 1,000-fold increase in the capability of the system. What that unlocks in the future is an exponential scaling resource for us to help solve problems that scale exponentially. One example of a type of problem that scales exponentially is computational chemistry. Because of the complexity in the atomic and molecular level interactions, the correlations in the parameter space get so big, so fast, that traditional computing, even the biggest supercomputers in the world, are just physically incapable of solving that problem beyond a certain point. And a quantum resource will be able to use its quantum mechanical properties to solve these problems that are beyond classical computing. So any industry that cares about the fundamental properties of molecules, so drug development, material science, chemicals, catalysis, all of these industries will be able to use these quantum resources to really redirect the way they do their R&D. A similar mathematical problem, but with very different applications, is in machine learning. Very large linear algebra problems are what quantum computers are particularly suited for, and so they will be very good at that. But I want to set some clear expectations here, and I think Dale actually worded it quite well. A quantum computer will act as an accelerator to classical computing. certainly for the first 10 years in these systems' existence, they will work in conjunction with classical computing to accelerate certain parts of the algorithm that they are particularly suited to do. They will not replace everything that classical computing does. Classical computing does a lot of things very well, and it will continue to do those things. And the other thing to keep in mind with this technology is it is still very much at its early stages. The prototype systems that are available, including systems from Rigetti Computing, you can access our 8-qubit system, for example, over the cloud. Today's systems are only as powerful as what can already be done on classical computing. So they cannot do anything yet that a classical computer cannot do. In the next 12 to 18 months, we expect that they will cross that threshold to where they can no longer be simulated classically. And as that happens, the application development in computational chemistry and machine learning will really start to accelerate over this period. And over the next 3, 4, 5 years, we'll start to see the first real applications, probably first in machine learning, and then soon after in computational chemistry. But the effects will be profound on these industries. The way R&D investment happens in these industries will change because you will now have a computational resource that can replace very often physical experimentation. And so the dynamics of those industries will change significantly.
Okay. Thanks, Madhav. Just pass it on to A-Star.
Hi, I'm Clem Lau. I'm just recently joined A-Star, a research group at A-Star in Singapore, led by John Gustafson, who has been there for just over a year now. And John's been doing research into universal numbers, or UNUMs, which is a different way of representing numbers in computer systems. So, but first of all, I wanted to digress a little bit. Is that I too was a computational chemist, a theoretical chemist. So it's fantastic that that at least I don't know if these two gentlemen are chemists also, but we're well represented here. So it warms my heart. But anyway, back to UNUMs. So UNUMs are actually the driving force for this is that IEEE 754 was a standard or a guideline established back in the 80s. And that has come through all the way with all the changes in computing, the different ways of computing. Dale talked about vector computing, multiprocessor computing, accelerators, quantum computers, whatever. But somewhere you have to store the numbers in memory, and we use this IEEE 754 standard. At some point in time, whether you use 32 bits, 64 bits, whatever. But we all have recognized in the past that there's something not quite right with the standard, in the sense that even if you take out your calculator and you divide 1/3 and then you multiply by 3 again, your calculator doesn't come back with 1, right? Or 6, divide by anything, multiply it again, you don't get back what you started with. So, but we kind of gloss over that. There are lots of algorithms that go through, and there are rounding errors. There are different kinds of things that happen that we are, if you like, in a sense that maybe we do certain things to take care of the accuracy, and we distinguish precision and accuracy in the sense that accuracy is how many significant digits that you have, right? After the decimal place, for example. And precision is like how many bits you're going to use to store that number. So we've gone through and we've said, okay, let's do double precision, right? In computational chemistry, that's what we do all the time. You just do everything in double precision, and it should be right. And then you find that, that if I did a calculation on this machine and I do a calculation on the other machine, the numbers don't actually match. And then also, if I do operations in different orders, I don't get the same answer either. So these are all issues that perhaps are with the way that these numbers are stored within the machine. So this universal number system is a new mapping system, and so we're hoping that we can generate a new awareness of issues with number systems, and that's why we feel that this could be something that's disruptive in the HPC.
Okay, thank you.
Thanks. Hi, my name's Kurt Rago. I'm with Mellanox. Not a chemist. I was engineer for high-frequency trading for 15 years. But just a little bit about Mellanox. I'm sure, I mean, I recognize a few of you folks because I've been to this forum a good few times. What Mellanox does, so we're basically a high-speed interconnect, if everyone's familiar with InfiniBand. So for the last plus 10 years, I think InfiniBand has been kind of a disruptive technology in the sense that it's not traditionally like an Ethernet network and so forth. But kind of in a nutshell, what Mellanox is doing in kind of the next generation, or what we're doing with HPC, is something more so called in-network computing. So in a nutshell, what that means is we're trying to make the network more intelligent. So rather than have your compute nodes and so forth doing all your computational thing for MPI runs and so forth, we're basically making the network more smart. So we're doing this with basically something called Sharp. So we're able to do aggregation and reduce with MPI within a switch rather than actually coming back to a node. Along with that, we're also making the network more resilient. We've got a technology, and you could look at our booth over there, called Shield. And what that does is actually is a self-healing network. So kind of in the tradition of like Ethernet, which I came from for X amount of years, you had BFD and so forth, where you had your network being able to heal itself, or just your dynamic routing where you could reroute around things. So what we're doing is we're making the network more intelligent and self-healing, and basically it's called in-network computing.
Thank you. John?
All right, I am not a chemist as well. I'm a mechanical engineer is my background. Worked at Pratt & Whitney for 5 years doing a lot of some HPC back in 2002. And then I worked at the National Lab, Idaho National Lab, for 6 years helping run clusters. And now I work with the workload management side of how do we provide these systems. And so as a user of HPC back at Pratt & Whitney, there was a lot of things that I learned. And from a disruptive technology, I defined a disruptive technology as something that allows me access to something I didn't have before. And I remember back in my school days learning about neural networks. But I heard nothing about neural networks from about 2000 to 2012 because the technology wasn't there to really take advantage of that power. And now we're talking about neural networks as this powerful, disruptive, deep learning, machine learning type of thing today. And what happened? Well, we knew about it, but now the technology from the computing side, GPU side, network, all of that, the data side is there so that deep learning with neural networks is now available. And so that was, I think, a disruptive technology, but it didn't happen. It didn't happen back when neural networks were being studied in the 90s because we didn't have the computing resources, and now we do. So it's just how do we make things that accessible to researchers and users to be able to progress and improve people's life with HPC. And so some of the things that Altair is doing in that vein is we're looking at ways of what are the current limitations that users are experiencing to get to access HPC. Now, as I went through college, Linux was new and exciting and all of that type of thing, and I was diving into that. My daughter, who's now going to college, knows how to use an iPhone, and she has no idea how to use a command line. And as we try to get that generation into HPC, how do we do that successfully? And as also we talked about during this conference, we know that the workforce is aging and is retiring, and a lot of that knowledge is going out the door into retirement because the younger generation is not learning to do sysadmin work due to cloud vendors and other people providing all these things for them, and they just get an app on their phone that works. And so we're looking at providing different ways that scientists, or these new scientists and new engineers, can access HPC without having to know how to run a command line, can use those tools to make it available. Another thing we're looking at is there's a lot of data in workload management about how users are running jobs on the system, and can we use that technology to provide a better information to the clusters, to the admins, to the sites, so they can have a better idea of how their users are using the system and what improvements do they need to make in their follow-on systems, or how can they help the user community better use those systems. So those are some of the disruptive technologies we're looking at, is not really the hardware coming down the road, but how do we make it more accessible to the users so they can drive these innovations down the road without having to have the expertise that I grew up in, I had to develop in college.
Okay. Well, thanks again. So that was question number 1, and the audience paid attention. And so all in your heads have a certain score for all of these presentations, right? All of these answers. So we're going to go to the second question. Again, it's a 2-part question. When would this disruptive technology be truly available for HPC users? And how do you envision it benefiting them? So we're going to start with John on that side again this time.
All right. So the disruptive technologies we talked about, those are on the closer horizon. They're not quite quantum computing where there's something down there that we're still investigating. So some of the things that we've been looking at, like I talked, predictive wall time is one of the things we've been looking at. How can we better schedule jobs? Because we all know that users don't want their jobs to die, and they don't want to give you very accurate information about their jobs, so they all submit jobs that say, hey, I need it to run for 2 days, and it may run for 2 hours. And so all of that stuff makes it very difficult for us to schedule jobs, which also means that jobs on the system have to wait longer, which causes other issues. And so that's one of the things that we're investigating, we're researching right now using machine learning to do so that we can better schedule jobs, which some of the research that we've done so far indicates that we can reduce the wait times that jobs sit around to run while not impacting the high priority jobs on your system, which gets you better utilization and customers are happier. The next thing that we're doing that we're releasing the end of this year is something we call PBS Access Desktop. And in the past, if you wanted to submit jobs and you're a Windows user, which I know in the HPC world that's not too common, but in the manufacturing space and other things, they use a lot of Windows. And how do they, but we require them that they SSH their jobs over, that they copy their files over, that they have to do something from the command line, or we try to make these portals easy. And this, what we've done here is you go into the Windows Explorer browser and you can right click on a file and you say run it in the HPC. And it will stage your jobs over, run the jobs. You can see all your files on your Windows box as they're running in the HPC. And then when the job is done, we copy all the data back, and the user did not realize that they left to go run on a Linux cluster. And it could be anywhere within their company or in the cloud. And so that's one thing that we believe will provide HPC, will sort of disrupt the current model and make it more accessible to the users. The next thing that we've been doing is also something we call the HyperWorks Unlimited and the HyperWorks Unlimited Virtual Appliance, where customers, they need to get their work done. We, as Altair, we provide HPC software, but we also provide CAE and CA, CAD and CAM software to do lightweighting. And so using that software, using these appliances, we can sell them a solution that has all the HPC capability as well as the software and the licensing so they can run their jobs, and we can deliver that in the cloud in less than an hour from when they ask for this whole solution. And we can also deliver it in the physical appliance for their site within within 6 weeks or something like that, and they can actually have the physical resource versus the typical procurement, install, and setup. So those are some of the things that we are doing in the disruptive space to provide value to our customer, and the HyperWorks Unlimited is available now. The PBS access for the Windows desktops to submit is available later this year, and the predictive wall time will be available next year.
So currently, we're actually, for disruptive technology, it's available right now. So I'm sure many of you folks are familiar with EDR. EDR is enhanced data rate, so it's basically 100 gig for InfiniBand, and that is available now. And at our table over there, you can take a look later on. We've got Switch IB2, which is out right now. So Switch IB2 is our second generation of EDR. Our first generation was Switch IB. What we did with that is we did that in conjunction with ConnectX-4, which is our first generation of 100 gig EDR. We came out with ConnectX-5, which was our second generation of EDR, along with Switch IB2. And what Switch IB2 does, and what I explained before, was it gives you the ability to do collective offloads within the cloud or within your network. So basically, you're building a tree within your network, and instead of having to do, have, let's say, for example, 10,000 jobs come back to a main process and go through one single port, we could cut latency down from 30 to 40 micro down to 3 to 4 micro. So that's currently what we have there right now, and obviously we're building a next generation, so we're always advancing our chipset. And I think, I'm sure some of you were at SC this year, I should say last year in November. We're coming out with HDR. So HDR, and I beg to differ the name rate, but we did enhanced data rate, now it's higher data rate, which is going to be 200 gig, right? And then we're coming out with Sharp version 2. So basically, what that's doing in a nutshell is it's taking advantage of more things that are going on in the machine learning where we have bigger message sizes and so forth. It takes advantage of a lot of the frameworks out there like PGAS, SHMEM, MPI, and so forth. And what people will see is application performance, right? So you're going to see basically, and what I explained before, what our big kind of disruption is making the network more intelligent and doing things outside of the compute. So rather than having to hit the stack every time when you want to process a network packet, we're able to do this in the network now. So that's one portion of what is doing that. And obviously, we've got, HDR will be available Q1, or actually, I should say Q4 this year, Q1 ready. And then, next generation, we're looking at, 400 gigs. So, we're just keeping, obviously progressing more and more and more and more. And, obviously keeping latency down and letting compute do compute and making the network intelligent in that respect.
Thanks.
Sure.
Can you start?
So UNAMs are now in this current iteration, as I said earlier, is a mapping of numbers. So we now have a direct drop-in replacement format for IEEE 754. So what's holding us back right now is for hardware manufacturers to adopt either UNAMs or posits, as we're calling them now, the third generation posits, and making them available as an alternative to with IEEE 754, or going straight to just using posits. The benefits from that users can get are you get repeatable, portable numbers, calculations. It's better closure in the sense that a lot of arithmetic operations, now you get better closure so that you don't get all these nans, non-numbers. There's also the benefit of the same or better accuracy at lower number of bits, so we don't have to carry a lot of these bits in, giving relief from the memory wall, which is this massive amount of energy that's expended to read data from memory, from main memory into the processor. So these are the kinds of things that we're trying to generate awareness of this issue again, and then hopefully some vendors will start implementing that. Rex Computing in California is the first one that'll do this, and we're looking forward to a lot of other companies to follow.
Great. So there's two things that have to happen in order to make quantum computing technology useful. The first one is you have to actually build scalable hardware. So you have to take quantum bits and turn them into the equivalent of a quantum integrated circuit that you can actually scale up. That is a problem that we have solved at Rigetti Computing. We design and we fabricate our own chips, and we've now deployed them over the cloud in our platform. The second thing that has to happen to make quantum computing useful is you have to write software and applications that can actually run on these systems. The thing that's held back the development of software and applications for quantum computing is the lack of availability of hardware. There's now 2 vendors in the world that actually have a cloud-deployed quantum computer. One is IBM, and the other is us, Rigetti. And so the acceleration in application development will continue over the next several years and start to really catch up. People have believed for a long time that you would need to build very, very large quantum computers to do anything useful with them, that they would have to be fully fault-tolerant machines. That preconception is not true. Some of the work that we're doing with NASA-Ames, for example, is to discover and develop hybrid algorithms that take advantage of this classical quantum architecture that I talked about earlier, and use these early quantum systems to really drive applications in machine learning, and in NASA's case, logistics, scheduling, those kinds of problems. Those will start to emerge over the next 3 to 5 years. And our partners tend to be organizations like NASA, some of the large research labs, many of whom are represented here, as well as very large corporate organizations that are already investing in building their own internal capabilities for developing and utilizing quantum applications. These organizations will build a significant advantage in their fields if they're able to gain a 2 or 3 year head start in developing applications for quantum computing.
Okay. I'll answer the parts in reverse order. In terms of how I would see HPC researchers using deep learning, you could imagine a pretty complicated taxonomy of ways that DL techniques might be integrated. In the pre-processing phase as either a filter or as an intelligent predicate. So you could use inference to kick off different jobs or different methods depending on what data was coming in. Certainly during the computation or the mod sim phase, you could both envision deep learning as part of the solver. So things like, as I mentioned, the ANI-1 research and some of the other research into density functional theory solvers based on deep learning, as well as imagining the mod sim being used as a trainer for DL using GAN techniques. So you would essentially use the modeling and simulation code as a way to adversarially challenge the deep learning stack and improve its parameterization of the things that you were trying to model. And then finally, of course, the ways that we traditionally think of deep learning is as a post-processing step, as a way to filter data. And you can look at the work that was announced last week by NERSC, where they achieved 15 petaflops on a deep learning weather simulation. They've actually previously done recognition of cyclones and other weather phenomena using semi-supervised networks. So you can think of this as a pretty useful and tool that integrates into existing workflows in a bunch of ways, either in the pre-processing, post-processing, or directly in the computational steps. And none of those, involve displacing HPC researchers and replacing them with guys with long hair and tattoos. In terms of when it's available, the NSF has some computational resources now that are pretty darn good at deep learning. The Bridges system, the GPU partition in Blue Waters, but I suspect that the coming systems, the Coral systems in DOE and some of the other systems that are coming post Volta, when we've really improved the deep learning performance while retaining our mod sim 64-bit floating point performance, as well as our rendering performance, will really open things up to a lot of researchers.
Okay, thanks. So that brings us to the last question. Now, obviously, the vendors have already seen the question, so they have kind of bleeded into the other question anyway. Again, this question also has 2 parts, but maybe I'll ask all of the representatives here to maybe focus on the second part of the final question, because most of you have already kind of addressed the first part of the final question. So this is the last question. So given that machine learning is a current buzzword and is a major theme of our forum here today, would your disruptive technology enable it? And that's where I said that most of them have already answered it. But I would like them to focus on the second part, is should we be concerned about AI? There you go, Dale, you start off.
Well, yeah, we sell GPUs. Mic drop. And I was actually going to give this answer whether or not I'd seen the third question. So I think you should be I think it should be embraced. Concern is a loaded word, so concern can mean, worrying yourself about it because it's out to replace traditional mod sim. And I heard that discussion a lot over the last couple of years, less so over the last 12 months, but certainly, 2 or 3 years ago, I was routinely getting an earful from HPC colleagues about this AI buzzword thing that really just has to go away because, it's just a bunch of Silicon Valley guys trying to make your phone listen to what you say. In terms of NVIDIA, not only do we make hardware that's amenable to deep learning, but we actually have a pretty substantial software footprint as well. Our code base you can think of as some place between the size of the Linux kernel and Windows. So it's a pretty substantial chunk of code. And we're trying to make sure that is enabled for deep learning, not just as a way to do image recognition or as a way to help self-driving cars recognize pedestrians, but as a general purpose tool that not just supporting the CNNs that do image recognition, but supporting the full range of DL techniques, including things that we haven't thought of yet, by making sure that all the frameworks are supported. Things like Keras work, all the solvers are supported, that we integrate well with networks and existing software stacks, so that you really get this kind of, for want of a better term, this kind of universal computing solution that's great at mod sim, that's great at taking data and reducing and rendering it, and is great at inferencing. And as to how that impacts you guys in the audience, I leave that to you. But I'll end on, we are not trying to replace you with a bunch of Silicon Valley hippies.
Okay, thanks.
Well, I live in Silicon Valley and I've been called a hippie, so I guess we come in all shapes and sizes. So the machine learning potential of quantum computers, I think, is an interesting topic. There's more to be done there. The number of algorithms available today on the machine learning side is still early. Some of the work we're doing with NASA, like I mentioned, is actually exploring the potential applications here. The broader question about what the outcome will be, I think there's two answers to it. Will a new technology paradigm like quantum computing affect the quality and the impact of artificial intelligence? Yes, it probably will. Do we know exactly in which ways it will do that? I don't think we do at this stage, mainly because I don't think the applications are yet sophisticated enough for us to answer that question. But I think the second question is, and we ask ourselves this as a company that is trying to build a new paradigm in technology all the time. Technology, every generation of it that has come out that has changed the world in positive ways has also had, extremely destructive tendencies. In fact, the impetus for creating new technology has often been driven from a more destructive angle. And so I think the responsibility is not just on the people that create the technology, but on the people that use the technology to be able to use AI or machine learning or computational chemistry or any of these applications that really drive productive uses. And it's incumbent on the people in this audience and others to make sure that happens. I don't believe the concerns about AI are entirely unwarranted. At the same time, I don't believe that those concerns mean that we do not pursue these technologies that have the ability to profoundly impact the world in many positive ways. And the responsibility just lies with what we end up doing with it.
Great, thanks.
So with the adoption of UNUMs or posits, we can definitely speed up both machine learning, deep learning, or AI, all three sectors, because they don't really require 32 bits or 64-bit precision. Many of these algorithms only require 8 bits. We lower the energy consumption, and we can speed up the calculations while maintaining the same or better accuracy. So we feel that this would be a great benefit to researchers and scientists in this area. And so absolutely we can enable this kind of research and enhance it better. The only, I think, from a different perspective, the only thing is, presumably machine learning, deep learning, AI is to enhance our quality of life, or and all of us here in HPC and whatnot are working towards that. How do we, use technology to make better technology to make, life better for all that? But I think one of the things, a book on my desk that I haven't yet had a chance to read is Thanks for Being Late, written by, I forgot the author's name, but he writes for the New York Times. And so the issue is, like, we're moving forward at light speed or at quantum speeds. Not everybody is doing that. So what do we do? How do we, take care of the rest of the society as we are blazing forward? So,
Thank you.
So I think the way that, it's kind of a big, larger question, but AI has been around for multiple years. I remember seeing books on my dad's desk when I was a kid. But I think how Mellanox could complement that is with, obviously we continue to grow our data rates, right? So again, we're at EDR right now. We're coming out with HDR next year, I should say the end of the year. With machine learning, AI, you're going to have larger message sizes. With our in-network computing and technologies to help process this data better, this is going to complement that. AI it's an interesting topic. I was reading a bit about intent-based networking, which is kind of a unique topic where now you can make your network smarter. Is it going to eliminate network engineers and so forth? I doubt it, but I just think that the logic is being pushed out to the network, which I explained earlier. And we also, and just to rehash a tiny bit about Mellanox, we're complete end-to-end solution. We also have Innova, which is an FPGA solution that we use. We just released an SoC, which is called Bluefield. So we're doing system on a chip. So we integrated our ConnectX-5 with SoC, so you could do NVMe over fabrics with that and storage and so forth. So I think everything, all of our technologies in a nutshell will actually kind of complement the whole AI model.
All right. A while ago, one of my favorite shows was called Person of Interest, which was about this artificial machine that could see everything, that had access to the NSA feeds, and that could track you, and it would indicate a lot of things. And that show's whole premise was this AI is a bunch of functions. It's a bunch of things that it's evaluating to determine what decision is the right one to make. And in there they talked about morals and how can you program a machine so that it properly handles the issues of humans. So, that is a little bit of a base. And we go back in time and we look at cell phones. I remember when the cell phone first came out and they had a GPS on it. Everybody was worried about the government tracking you everywhere and everything else. And there was always, someone will always know where I'm at. At the same time, I hated to travel at that time. And as soon as I started to travel more and I had a GPS, I felt so much freer and so much able to do things and go to places all over the globe. And that enabled my life. It freed it up. It made it so I was comfortable doing things that I was no longer comfortable doing. I see that same argument happening right now with AI. Will AI be the person of interest, dominate my life? Will there be decisions made? Or will AI be this enabler like the GPS was for my phone that frees me to have a much fuller, richer life? So I see AI as that. It's really coming down. It's improving the way we do traffic flow. It's improving I love it, pulling up my phone and looking at Waze or something like that and knowing which traffic routes to avoid. And all of that, a lot of that's been enabled by machine learning, deep learning, and other things. And I like going to Amazon and seeing that it predicts, it says people who bought this have also bought that, and that gives me a way to quickly find things that I would not have normally searched for. So I see AI with these driverless cars and other things they've talked about with medicine. No doctor can read every medical journal that comes out, but they were talking about how Watson or those type of forms could read it and help the doctor be more informed. So when I'm asking the doctor for information, he can give that to me and say, yes, I've looked at all this, and this is the latest research, and here's what we'd like to do, versus him trying to keep up with everything, which we know is physically impossible with today's information age just swamping people. So I see AI as a very exciting thing coming forward, but it's also something we need to pay attention to, because at the end of the day, it's evaluating functions and scores and what's the right value for this score. And if the model that it's operating off is not correct, then we're going to have issues. And so we just need to be aware of what model is it using, and is that the model that we want to be feeding us information. So that is where I see AI is going. But from a manufacturing standpoint, it's great to help engineers hone in on designs where they can put in parameters, and it can go explore the design space with the engineer guiding it and training it. And that's where I see the value of AI really coming forward from a manufacturing engineering space to improve the way we do transportation and improve the way we provide solutions to customers to improve their lives.
Okay. Well, thank you. Okay. So, given that we had one less panelist, and given that I had come up with these 3 questions, and since we have 8 minutes plus, we're now going to take some questions from the audience. So, do we have a microphone or something additional, or no? Okay. Okay.
Yeah, we have one up there, and I think they
Do we
can
have-
share the left there.
Well, there's only one here.
No, they've got the left there.
Okay.
If I grab that one, okay.
Great. Yeah, so please ask the question, and then if you want to direct your question to a specific company, then go ahead and do that as well.
I want to make a short comment, Gabriel Bronner from Rescale. I think we like to say disruptive technologies, and maybe I have to blame my friend Rupak for that. I think you guys have all done great innovations. So if I listen to Altair saying, you'll be able to predict how long a job is going to take, that's useful. That's innovation. That's valuable. And to me, innovation is a fresh idea that creates value. It fits that category. For me, disruption is the disk industry was this expensive hard disk, and RAID came along, low cost. It disrupted the business of the big companies. So when you say disruptive technologies, I wonder if we should change the question and say, what are the innovations you're working on, and how are they bringing value to the future? And I think they all fit in that category, but I'm not listening business being disrupted immediately from the things I heard. That's my only comment.
Anyone want to rebut that comment?
Intel didn't show up.
Your mic is off, but I think you said Intel didn't show.
Apparently, we scared Intel off because they're not here today.
Okay, maybe you can say NVIDIA's disruptive Intel, for example, something like that. Okay.
Any other questions? There are a couple of questions on this side, or
Can you just pass this down?
Hi, this is Said Korj from NCSA. I have a question for a colleague from Rigetti. One of the known problem for quantum computing is actually keeping the temperature close to absolute zero, right, to 0 Kelvin, and then it's pretty much against the physical laws that we know of heat transfer, So how you guys address this issue? It's interesting you haven't mentioned that, and is that something that you'll maybe resolve, or how is that going to work? Thank you.
Yeah, that's a good question. So for some context, many approaches for quantum computing, the one that we use relies on circuits on silicon, but these circuits operate in a superconducting state for them to actually behave quantum mechanically. And in order for them to behave, to have superconducting properties, they have to be cooled down to cryogenic temperatures. And so our cryogenic systems, for example, run at 10 millikelvin, which is in the order of about 1,000 times colder than deep space. The cryogenic systems are neither the most impressive nor the most complicated part of the technology. Over the last 10 years, these systems have gotten extremely robust to the point where you have global suppliers that supply these systems, and you get them, you install them, and you put on a switch and they just run. So cryogenic systems certainly are not the part of the technology that keep us up at night. There's a lot of other critical engineering problems that have to be solved, not to mention all the work that has to happen on the software side. There will be space constraints and eventually mass constraints as the systems continue to scale up, but those again are engineering problems to solve that aren't inherently because of cryogenic systems. The other thing that's true for these systems is they typically run at about 20 kilowatts, and if I remember the presentation from yesterday, most supercomputers run at about 25 to 30 megawatts. So from an energy consumption perspective, you will get a resource that can do things that supercomputers cannot do at about 1,000 times more energy efficient. So it's not a constraint. It's not the one that we're concerned about. I don't believe it's going to hold back the field, for the next 2 or 3 decades.
Yeah, just wanted to add on that. Yes, so when we installed the quantum computer at NASA, the D-Wave system that we had, one of my concerns also was, well, how the heck are we going to get these systems to be cold at 10, 15 millikelvin, where deep space is at 3 Kelvin? And apparently that was not the problem. Apparently, like Madhav said, that is the least of the problems. You can probably order it off Amazon right now.
Let's hope
Okay.
not. The
Yeah.
drone will drop it. So this is kind of a left turn question, but really pokes at some of the comments in the last round of discussions. So I kind of live a life of just because you can doesn't mean you should. And I think that there are some important, useful, ethically and morally focused applications of AI. Some of you talked about it, better engineering, healthcare and whatnot. But I feel like as technologists, we're going kind of like, just because we can, it's cool, it's the new shiny penny, and we're going to try and apply this capability to everything we do. And I think we have to be really mindful of that. And I guess the question is, what role do you believe corporations have in being a moral and ethically focused conscience around the application? What role? I mean, NVIDIA is hell-bent, AI everywhere, we're going to embed it in every application, this one's doing that, this one's doing that. Number one, what role do corporations have? Number two, what role do you have in making sure we don't have massive economic dislocation through hyper-automation? So I'm putting this out to the community. Who are we? What do we become? Do we just provide technology? Or do we actually dig in and make sure that we're reskilling people, that we understand the ethical and moral implications of this technology? So here we are. We're at a point in time. So I'd be curious of your comments on that.
Okay. Thanks, Deborah. You have to answer the question at the end, though. But before that, we'll ask them answer the questions, and then you will answer the question. Okay? Sounds good? Okay, go ahead.
So I don't disagree. Corporations are not always the best position to enforce a moral code on the things that you produce. Meaning, for instance, AI is going to exist whether we provide a DNN library or not. It predates it predates NVIDIA as a corporation. I worry more about, less about AI as an out of control force and more about AI as a reflection of the people creating it. Meaning that, AI gets trained, and you can train an AI network with all the human failings and prejudices and shortcomings that exist, and then point at that network as, the inference from that network as, well, look, the AI says that person X is inferior or this or that or should, do whatever. That's a human problem, not an AI problem. It's a human problem in that we're creating the bias, and it's a human problem in that as the Milgram experiment and other things have shown, humans are more than willing to go, oh well, someone or something else made the decision, and going along with it. So, yeah, I agree on that level. There's always room for concern, but there should be room for concern there whether AI exists or not, because people are, pretty good at being crappy given the opportunity.
Is the scale?
Anyone else has a comment?
Yeah, I actually want to talk about the second part of the question about job displacement. One of the things, and by the way, I'll respectfully disagree with Gabriel's point about these technologies not being disruptive, but we can argue about that maybe at a different time. But one of the things that we're excited about, specifically when it comes to quantum computing, is that the set of problems that quantum computers will unlock are incremental to what we can do with computers today. So if you could use the technology to more quickly design and discover new materials, there may be more drug compounds that we could actually explore that will require more chemists and require more doctors and require more testing. If you designed better artificial intelligence, for example, for automated vehicles, most projections say that the number of vehicles in the road will go up. Now that may cause other problems for us, but I don't think the automotive industry is going to go away because we have self-driving cars. If anything, cars may become more prevalent. I think one of the things that will happen is if you allow technology to augment the things that we're doing today and really focus on the problems that have been unavailable to us before, I think it will actually have a positive impact on the jobs that are created out of it. And that's what we're hoping to achieve.
Okay. I think John wanted to say something.
Well, my comment is I would argue each one of us is an intelligence. And each one of us has gone and been trained. And we've gone through college and we've done other things to train us. And now we talk about what's an artificial intelligence. I would look at that and say, that's maybe my politician. He has a lot more control, or it's the mayor, it's the governor, or the president, or whoever. And they have gone through and training, and they have power over us in some regards that we need to look at and be aware of. How are these people affecting our lives? And we go to the polls and we vote and do other things to try to minimize the power or give certain power to other regions over our life. And I would say that artificial intelligence, corporations have power over our lives in the sense that we give power to Amazon when we go there and buy things and support their business, and that they go and improve and invent. And so I agree that we need to be very conscious of who we're supporting companies-wise. Are they going down the missions that we want to support and other things? But I don't think we can say, yes, corporations have a responsibility, and I believe they do have a responsibility, but that just because I say they should have a responsibility doesn't mean that they will take that responsibility and do it in a way that I approve. And if we say let's limit it here in the US or other places around the world will take AI and explore it, because at the end of the day, they're going to do things that bring in money, that generate revenue, business, and cash flow to their companies. And so if we, as people, support it, similar to China in manufacturing, they were able to create things at a much cheaper cost than the U.S. As long as we in the U.S. kept buying that, they would keep producing that, and the businesses in the U.S. would have to adjust accordingly. So it's really how concerned am I personally about it, and will I be attentive, and will I change my lifestyle to properly reflect the values to support those that are doing the things in the AI and other areas that I believe is honorable and moral and other things.
Okay, thanks. And so, Deborah, do you want to give some parting comments?
I guess the only thing I would say is, so there was a recent, before Jeff, GE senior executive management has been, this is an example of corporate responsibility. Okay, so GE got, many years ago, slammed for environmental impacts, and I think they woke up that when you do bad things to the environment, it actually impacts you financially, right? So there was a moral underpinning, but also a financial one. And this time, as they move into things like predicts and IoT and hyper-automation in manufacturing, they have been very explicit about saying that they're digging in around job reskilling and making sure that they are not going to carve out and destroy the economic foundation, because, I mean, there are things that actually will accrue to this over the course of the next couple of decades that are beyond what you could even imagine in terms of economic changes. So there may be more cars, but there aren't pizza drivers or bus drivers or delivery vehicles, where do those people go? Who's reskilling them? Who's responsible? Do they just sit at home? What happens to healthcare? You move to a gig economy because all these things are in transition because of hyper-automation. Do you carry your healthcare with you? I mean, there are real things that are going to happen over the next 2 decades by virtue of hyper-automation. So, do I think corporations have a responsibility? I do, because I don't think the governments are taking responsibility on this. So corporations, if you're going to create products, they're going to have explicit impacts on the economic structure that exists today, you have to be mindful of what you do to backfill. So I actually believe that we do. And I think that, you know, we have an ethics group in Intel right now looking at that very closely because we get it. So are we going to do anything about it? Who knows? But at least we're talking about it. So I do.
Okay, thanks. We'll take one final question. I think Mike Garris here has a question, and then this is perfect to discuss over lunch or beer or drinks or whatever.
Yeah, it's not a question. It's actually in response. So I very much appreciate the perspective. And so I can say that a lot of the concerns that you just vocalized are motivations and drive behind the subcommittee out of the White House that President Obama started, continues under President Trump. And the whole debate and expectation and of what the economic implications are going to be. So it's a bit of a segue to some of the comments I'll be making later on today. But in fact, the federal government is paying attention to this at some level, as you will hear.
Okay. So thanks again. Just so you know, Mike Garris is the co-chair of this OSTP subcommittee on machine learning and artificial intelligence. I'm actually the NASA rep on that subcommittee. And so we can all talk about this. I think we have one more thing before the break, correct?
Correct.
Okay, so let's thank all the vendors and all the speakers, you know.